Okay, chapter 13, day 1. We're going to start to look at what are the components of observations and experiments. So this chapter is about observations and experiments. We're going to first just run through all the vocabulary that goes along with it. So, first piece, observational study. In observational study, you observe the subjects. No treatment is given in an observational study. You're looking at data that you've gathered, maybe from medical records. You're looking at objects and what they're doing, but you're not providing any kind of manipulation, no treatment. There are two types. One is called a retrospective, and if we think about the word retro, that's in the past. So a retrospective study identifies subjects, okay, what is it that I'm studying, and looks at past behaviors. So that's identifying people and look at their maybe previous medical records. Identifying people that currently have a disease or an illness and looking back at their past behavior that might have contributed to it. The second type is called prospective. Prospective identifies subjects, okay, who or what am I studying, and follows them into the future. So identify people and now watch them into the future. That is a prospective study. We're still not giving any treatment, but we're watching what happens in the future. An experiment gives a treatment. All right, there's some sort of treatment given. It isn't always a pill or a medicine. A treatment could be two different type of directions to read to accomplish a task. The treatment would be the directions that they got. So it isn't always a pill or a medicine. So the treatment is given to the subjects. The only way to show cause and effect is to do a controlled experiment. You know, when we talk about does this seem to cause that, the only way to show that is to do a controlled experiment. So, some other vocabulary words. Factors. Factors are the explanatory variables in the experiment. It is what is being inputted as the treatment. The factors are what you're doing to that subject. Levels are the different values of each factor. So you have a factor of what you're doing, then you might have different levels of that factor. Experimental unit is who or what the experiment is being done on. If it's people, if it's people, we just call them subjects. Sorry, the board froze. If they're people, we call them subjects. If they're not people, we just call them experimental units. So if we're testing frogs, we're not going to call them subjects. They're just experimental units of frogs. Next piece of vocabulary is, well, that's it for vocabulary, but the next piece, what if I wanted to design an experiment to test the breathing rate of fish at 50 and 60 degrees with high, medium, and low salt levels? So let's say I wanted to design an experiment to test the breathing rate of fish at 50, 60 degrees, high, medium, low salt levels. So if you can think about it, I'm going to have fish tanks, and in those fish tanks are going to be different water temperatures and different salt levels. Experimental unit, in this case, would be the fish. Factors. There are two factors temperature and salt level. Factors are general. There are the general items that what you're manipulating your subjects with. Temp and salt level. Now, levels. There are 2 levels of temperature, 50 and 60, and there are 3 levels of salt, high, medium, and low. So the levels are the specific values of each factor. So in this case, we might have a fish tank with 50-degree water, high salt, 50-degree water, medium salt, 50-degree water, low salt, 60-degree water, high, medium, and low. 6 total treatment, 6 total fish tanks. We would have to break these fish up into 6 groups. Some more vocabulary. Statistically significant. There could be differences in your results, but for the difference to be statistically significant, the result has to be too large of enough of a difference that it couldn't have happened by chance. It has to be a big enough change, a big enough difference that it just couldn't be happened by chance. If that happens, we say that those results are statistically significant. Blinding. If you think about blinding, you can't see what's going on. And in experiments, blinding has a couple different variations. Single blind. Either the subject, the person getting the treatment done to them, or the person evaluating them don't know what treatment the subjects receive. So, for example, if I'm taking a pill, I shouldn't know if I have the medicine that they're trying to study or some placebo. An evaluator would be like a medical doctor. If only one of us knows what's going on, the other person is blind, that's single blind. But if we both don't know, that's called double blind. Both the subject and the evaluator don't know what the treatment the subjects receive. Double blind. And when we both know what group we are in, then there's no blinding at all. So for example, let's say they're studying effects of exercise on weight loss, and you either run 2 miles a day or walk 5 miles a day, and those are the 2 groups. Would you know what group you're in? Yeah, I would know if I'm in the running group or the walking group. You can't blind me from that. How do you measure weight loss? With a scale. There's no blinding of the scale or the person looking at the scale. They're going to just read a number. So there's no blinding needed at all. Now let's say the experiment was walking or running. Does it change your skin complexion? Well, again, you can't blind me because I'm either walking or running and I know what group I'm in. But to measure what my skin complexion looks like, I would want to single blind then the evaluator so they don't make a judgment based on what they think helps skin complexion. They can just look at my skin complexion. So you just have to ask yourself, who doesn't need to know? Who should not know? Someone always knows, the person that runs it, but out of the subject or the evaluator, who does not know? Lurking variables. When other variables that we are not trying to study have an impact on the result, then they are lurking in the background, lurking variables. Skin complexion, for example, walking, running group. What they don't know is I'm out at the tanning bed as well, and that might have affected the results. So it'd be a lurking variable. Explanatory variable is the input. It's what we're putting in. It's the factor. It is used to determine the result we get. So, like the water temperature and the salt for the fish tanks would have been the explanatory. It's our input. It's what we're doing to the subject. The response variable is the output. It is what we're measuring or what we're recording. And in this case, it would have been the breathing rate of the fish. All right. Last piece are the different design types. One, completely randomized. That's where the groups are selected randomly and everyone's assigned randomly to the groups. One is called blocked. That's where people are separated by a common characteristic first, and then they still maybe get randomized on what happens after. But you're separated by a common characteristic. We think medicine affects males and females differently because of genetics. So we might first take the males and put them over here, the females put them over here, then within the male group, placebo and treatment, within the female group, placebo and treatment. And the last one is called the matched design, in which groups are alike as much as we possibly can make them. And a lot of times you are your own control group. So for example, does practice bowling improve my performance? I bowl a game and then I practice and I bowl another game. I'm actually my own control group. We are matched. Now, it's not always you that you're your own control group. We might just do a design in which groups are matched on where they live, where they work, what type of race or ethnicity they are, so that way we can try to rule out some of the genetic pieces, some of the environmental pieces, and we would just match them on characteristics. But you are your own control group if it's done on yourself. And that's it for chapter 13.